Okay, here are a couple more examples of quadratic equations that I wanted to graph. They're in the standard form, and I wanted to find the vertex and go from there. So let's get right to it. So again, here's the strategy for finding the vertex. The approved strategy a lot of people find or use. Okay, to find the x value of the vertex, I'm going to do my negative b over 2a. Over 2a. Now, notice something here. We don't have a something times x. We have x squared, we have 1. So what that means is that we have an a and we have a c, but we don't have a b. If I were to rewrite this equation, it looks like 1x squared, we could say, plus 0x plus 1. So b is equal to 0. Okay, so I put in a 0 over here. It doesn't really matter what this is unless it's 0. And we're just going to call that 0. 0 divided by anything is 0. How about the y value then? Okay, so again, the typical sort of approved and shown way to find the y value is to plug that x value back into your equation. So y is equal to 0 squared plus 1, which is 1. The vertex, therefore, is located right here at 0, 1. Now, what can I do with that? It helps me set up my little table of values. If I'm graphing by finding some numbers using a table here, the vertex I'm going to call my central point, and then I'm just going to go around that a little bit. The more points you get, the more accurate your graph is. So let's just say -1 here, -2, 1, 2, and find the corresponding y values by plugging in the points. So for this one, y equals -2 squared plus 1. 4 plus 1 is 5. Plug in this guy, y equals -1 squared plus 1 equals 1 plus 1 is 2. Now remember, since we went around the vertex, we already know what this value is. It's 1. I can copy the other two values in that I just found. Sorry for the tiny writing here. Big mistake on my part. Zoom in, I guess, right? I already know these other two values by symmetry, right? This one's got to be 2, and this one's got to be 5. Feel free to verify that yourself if you would like. And so the graph, it appears, I need some positive, negative values of x. Positive values of y, of course, look something like this. Try not to run out of space here. There's -1, -2 for my x, 0, 1, 2, and then I need to go up to 5 on the y-axis. 2, 3, 4, 5. And just start sticking on my points. The vertex is right here, 0, 1. Is it going to be upward or downward? Well, remember the leading coefficient was positive, so it's going to be an upward facing guy. That's how I knew not to draw more here in addition to looking at my table. And the other values are the following. -2 puts me at 2. Excuse me, -1 on the x puts me at 2 on the y. -2 on the x puts me at 5 on the y. And by symmetry, got the other side here. And connect it with the smoothest curve possible. And there it is, the curve that shows me all of the points that are solutions to this equation. Okay, here's another one that I just wanted to do that has a small fraction in the front. And let's take a look at what that looks like. Maybe you can pause me at this moment and find the vertex yourself, find a couple points, get the graph, and then hit play again and see if we end up with the same thing. So for my vertex approved method, I'm going to look for the x value being -b over 2a. Let me just write the numbers. -b over 2a is -1/2. Okay. So overall, I've got a negative and a negative here, which becomes positive. The first thing I see, just visually the way my mind goes, is these twos cancel. Okay, but what if you have 1 over a fraction? Well, just flip it over. Turns out that's the same thing. You can look at this as 1 divided by 1/2, and you can copy dot flip or use whatever gimmick you got, but 2 is what we come out with in the end. The y value of the vertex then, I'll get by plugging in 2 to my equation here. So y equals negative 1/2 times 2 squared plus 2 times 2 minus 1, which is equal to negative 1/2 times 4 plus 4 minus 1. This gives me negative 2 plus, let's just call that 3, which is positive 1. Therefore, my vertex is located at 2, 1. And let me just ask you, is this going to be an upward or downward facing? And of course, you answered it's going to be a downward. It's going to be a sad face parabola or quadratic equation because I have a negative right there in front of my leading coefficient. Now, if I'm making a table of values, what should I go around? I should go around the vertex, so let me do that. There's my XY table of values. Not to be confused with all this stuff. This classic math teacher jargon on the board. Okay, where am I at? 2, 1 is my central location here. 2, 1. So let's go around that. Let's go 1, 0, and 3, 4, and generate some points. And again, by symmetry, taking advantage of symmetry, you only really need half of this. The other half is natural. So let's plug in these y values. 0, that's always a nice one. Okay, negative 1/2 times 0 squared. Guess I could put parentheses around that. Plus 2 times 0 minus 1 is clearly negative 1, so I'll stick that on there. Plug in the value of 1. Negative 1/2 times 1 squared plus 2 times 1 minus 1 equals negative 1/2. 1 squared is 1 multiplied by that. There's my negative half. Plus 2 minus 1. And since I have some space, I don't need to calculate that one. I'll just go here. This is negative 1/2. Plus 1 is 1/2. Okay. Yeah, that looks good. So my 1/2 goes here. And I can stick another 1/2 here right away, and I can stick another negative 1 there without really even thinking about it by symmetry. Although I guess I should caution in general, taking the thinking out of things is generally a bad idea. Let me remove my calculation of the vertex so that I can put the graph right here. Okay. There we go. Alrighty. My parabola is downward facing, so the vertex in this case, and how do I know it's downward facing? Because of the negative on the leading coefficient. My vertex is therefore the top of this guy. That's the highest point. So I'm going to draw my graph like that. And I guess I didn't need this side. I should have paid more attention. I have x values going from 0 to 4. 1, 2, 3, 4. And there's my 0 y values. I need at least a 1 here. And you know what? I'm going to go by halves. So 1/2, 1, and down here, negative 1/2, negative 1. And I'm doing that because I see some halves in my data, in my values. So if x is 0, y is negative 1, I'll stick a point right there. If x is 1, y is positive 1/2. At 2, we've got y equals 1. That's the vertex. By symmetry, we've got these other points. And then we connect it with the smoothest curve possible. And there it is. Now, my graph, I admit, does look unnaturally steep, and that's because I changed my scale a little bit here on the y-axis. It's a little different than the x-axis. And so you do have to be careful of that when you're visualizing graphs and trying to determine their meaning as to how skinny or how wide the pictures look. Actually, advertisers use that a lot to trick you, so be careful with that. Graph this on a graph that has the same scale. You'll see it broaden out a little bit. So, all right, see you next time.